Okay, so 4.4, optimization. Optimization is when you're going to be asked to find the most of something or the least of something. Okay, so in calculus, what does that sound like? It's basically a max or a min. How do you find a max or a min? You find the derivative, you set it equal to 0. So, it's stuff that we do already know, okay? But we're seeing it in a different way, right? So basically, you have these word problems. And then in these word problems, the first thing you're going to do is you're going to make a diagram. And then after that, you're going to try your best to make an equation in one variable. So like in terms of x, in terms of r, in terms of width, in terms of length, whatever. So you want it to be like f of x or a of x or a of r, right? In terms of radius, whatever. So you really want it to be in one variable. And then number 3, like we said, you take a derivative of the optimization equation, and then you solve by setting that derivative equal to 0. And then, of course, you do your little number line, and then you make sure that the answer is correct. So if they're asking for a max, you should go from positive to negative for your derivative, right? If they're asking for a minimum value, you're going from negative to positive. So you always have to solve, and you have to put it on that number line to make sure. And then you actually make sure you answer the question. So just read the question again and make sure it's answered. You know how sometimes they'll be like, what's the perimeter? And you're like, x equals 5. That's not a perimeter, okay? That's like a side of the rectangle or whatever. Okay, so let's say you have something like this. So I wrote it out for you. We are fencing off some poisonous flowers along a river. The side along the river needs no fencing. Those poor fish. Right next to the poisonous flowers. Luckily, they don't eat flowers, right? Hopefully. Okay, what is the, and then the first thing we're going to do, we're going to find the greatest area we can fence off using 300 meters of fencing. Okay, so we're given a lot of information. Here's what I really like to do, and you should really do this, okay? So I underline my greatest or least. So you can circle, that's fine. So there's 2 things you want to do, though. You want to circle or underline whatever word you have to tell you if it's a max or min. So the greatest, the least, the most, whatever, okay? So circle or underline that. And then I box my optimization formula. So where I'm going to get my optimization formula. So they want the greatest area. Okay, so I need an area formula. So I want it to be a of x, okay? Using 300 meters of fencing. Okay, so I'm going to draw myself a picture. And in my picture, I'll go like this. So in my picture, I have x, one side is a river, and then the other side, if this is 300, then I can say that this is right here 300 minus these 2 x's, right? So if I add them all up, I still get 300. Do you have to do it this way? Can you put x over here? Yeah, you can put x over here, but you're going to have fractions on those 2 sides, okay? So, draw it however you want, as long as it makes sense, and then put your variables wherever you want, as long as it makes sense, okay? As long as it's legal, it's fine. I decided to do this because my numbers are a little easier. Okay, how do you find an area? Well, area is when you multiply the length times the width. So my area is x times this. All right, I'm going to multiply it out. Why would I multiply it out? Because later I have to take the derivative. So I'm going to multiply it out so I can very easily take the derivative. So then I take the derivative, I solve that derivative by setting it equal to 0, and then I check that derivative. So when I check it, I see right here, I have a 75, and then when I look at this equation right here, this is a line, right? This derivative is a line with a negative slope. A line with a negative slope goes like this, right? A positive slope goes like this, a negative slope goes like this. So if it goes like this through 75, then this is positive, this is negative because it goes like that, right? If I plug in a 0, actually probably not a 0, if I plug in like a 50 into here, and then if I plug in 100 into here, I'll get a positive and negative as well, okay? But I can see that's definitely a maximum, so I got my answer for x. Am I done? It says greatest area. What is the greatest area? No, I'm not done. So I need to finish that off and get my area. And then remember that your area, all of these problems probably have words. so then you have some sort of label. Okay? Okay, so the second part of that question is, what is the smallest area of fencing you can use? So here's the thing. If I were to do all that work again, I would get to 75, and I can see that's a max. There's only a max. So what is the smallest area? Sometimes we have to use our logic a little bit, okay? So when we're using our logic, well, how much fencing is possible? From 0 to 300, right? From 0 to 300. What's the smallest area from 0 to 300 for fencing? Well, it's going to be something like that, right? So I say, like, use your logic. You can have a 0 area. So you're thinking about, okay, I have from 0 to 300 for fencing. So this is these are, oh, you know what this is? Oh my gosh. This is extreme value theorem, right? Because it's really like, okay, well, what's the least? If that's the most, what's the least? So they're asking for you to check the endpoints. Do they tell you the endpoints? No, you're using your logic to figure out the endpoints of your domain. And then, so here, instead of just 75, now I have my endpoints, which is 0 and 300. I plug in 0, I plug in 300. It doesn't matter which one I plug in. I'm going to get 0 for my area. Okay, so that's the smallest area. So yes, extreme value theorem. Ooh. Okay, let's try another. So it looks really similar, but it's not the same. So this says, same situation, right? Looks really similar. What is the least amount of fencing needed to fence off this area, okay? So I circle or underline least. I want to find the least. I need to guarantee that later that it's the least, so it needs to go from negative to positive when I do my little number chart. And then I want a fencing. So least amount of fencing, I need a fencing equation. Okay, so the first thing I'm going to do is I'm going to draw a picture. So that picture still has, you know, water, and then it has 3 sides. And then I know that the inside, the area is 80,000. So if the area is 80,000 and x times something equals 80,000, then it makes sense that this would be x and then this would be 80,000 divided by x, right? Because if I multiply this and this, I get 80,000, okay? So I have to like draw a picture and I have to label the picture, okay? And then, what is perimeter of this fencing? Well, it's this and this, so 2 x's plus this. All right, so there's my perimeter formula in terms of one variable. And then, oops, I find my derivative, and then I set my derivative equal to 0. And then this gets added to the other side. I cross multiply, I divide, I take the square root. I can actually do this in my head, right? This is possible in your head. So there's 4 zeros, take the square root, you get 2 zeros. Okay, so you get 200, and then you draw your little number line, and you guarantee that it is a minimum. So it is a minimum, we're all good. Again, how could we get these values pretty quickly? Well, right here, it's not super quick, but you can plug in like 100, see what happens. So if you plug in 100, you get like 10,000, right? So you get a negative, and then you can plug in, I don't know, 300, which is like 90,000? Is that right? Yeah, 90,000. And then you would get some number that's less than 1, 2 minus a number, 2 minus a number that's less than 1, it's going to be a positive, okay? So I just check that that's true. And then, is that the answer to our question? No, it says, what is our fencing actually? So I just plug it back in, and then I have my final answer, okay? So this is a perimeter, it's not meters squared, it's just meters, right? Okay, so another kind of problem, let's see. So find 2 numbers whose sum is 21, and product is the largest possible. So I have to like read and reread the question sometimes. So what do they want? They want some sort of largest. So I want a maximum. And then really what they want is a product. So I want the product to be large as possible. So the product is what I want. I need a formula for product. How do you get a product? So I'm going to say P for product, okay? And then how do you get a product? You multiply two things together. What two things do you multiply together? Well, let's decide. There's no picture I can draw, but I can say that there's two numbers. The first number I'm going to call X, right? The first number always, like, let's just call it X. The second number, well, the sum is 21. So I can say the second number is 21 minus X, right? Because this plus this should give me 21. Okay, so what is my product formula? It's going to be different for all the questions that are like this because they're all a little bit different, right? So product is this number times this number. So I write it, I multiply it out, I find the derivative, I set it equal to 0, and then I put it on a number line. That is a maximum. Do I want a max? Yes, I want a largest. There we go. There's my product. Okay. So really it's like the product. So, find two numbers, sorry. Find two numbers. These are my two numbers. I don't want the product. I want the two numbers. Okay. So always, yeah, reread the question. Did you answer the question? Okay. So how about something like this? So find the number on the interval -5 to 0 such that the sum of the number and its reciprocal is as small as possible. So I have to really read this and decide, what do they want? They want the sum to be the smallest possible, okay? So something about a number and its reciprocal, but in general, they want the sum to be the smallest. So smallest is what I'm looking for. I'm looking for a min. Sum is the formula that I want. So I want two numbers, and then I want to add them together as my formula, okay? So my first number, again, I'm going to call it x. My second number, it says reciprocal. Okay, so I'm going to call it 1 over x. The sum is going to be, that, right? So you add them together. Okay, find the derivative. So you find the derivative. You set it equal to 0, and then you solve, and you get plus or minus 1. Okay, so plus or minus 1, you put it in a little number line, and then when you plug in, you get something like this. So you get a positive and a negative and a positive. So that is some sort of maximum. That is some sort of minimum. Okay, I'm looking for a minimum, but my interval is this. So is this between this? No, there's no such number in the interval -5 to 0. There is a number in the interval 0 to 5. There is only a maximum in that. And because these are not endpoints, right? This is parentheses. Because they're parentheses, we can't say that the answer is -5 or 0. Because -5 and 0 don't count. So when we have to go in between those, we can't use so because those don't count, we can't use the extreme value theorem because these aren't extreme values. They're not endpoints. It only works when there's literally endpoints, right? Otherwise, we can't plug them in. Okay, there's a few more, two more. Okay, what is the largest area what is the area of the largest right triangle whose hypotenuse is 10? Okay. So you're looking for an area of the largest right triangle, so largest area, okay? So I'm looking for area, but I want to find some sort of right triangle. I'm going to go ahead and show this. How about that? So my right triangle, and then it said this, right? So I know this is kind of crazy, but let's start with that. So this is a right triangle. My hypotenuse is 10. If I have a 10, I'm going to call one side x. It doesn't matter which side. How do you find the other side? Well, Pythagorean Theorem. So this squared plus this squared equals this squared. What can I call this? It's going to be the square root of 100 minus x squared, right? So if I wrote it out, I would write like x squared plus question mark squared equals 10 squared. And I solve for the question mark and I get that. Okay? So then I have this. And then I want to find the area. How do you find area? It's going to be 1/2 base times height. So here's my 1/2 base times height for a triangle. I find my derivative. Oh, this one's a little crazy, right? Because it's actually going to be this quantity times this quantity. So it's a product. It's that times that. So 1/2 x times the derivative of the radical, and then plus the radical times the derivative of 1/2 x, which is just 1/2. So remember, the 1/2 comes forward. This is the inside to the negative 1/2 power, and then times the derivative of the inside, which is negative 2x. So this is a product rule. Okay, it takes a little bit of time to set that equal to 0 and solve for x. You guys should do it without just copying me. And then I made it a little bit neater, and then I moved one of them to the other side, and then I can cross multiply. So really this is just like algebraic stuff, right? So after I cross multiply, I solve for x. I get x equals root 50, and then I put it in a little number line. When I put it in a number line, I'm using, what am I using? I'm using this one, okay? So if I use like, what's less than root 50? Like 1. 1 is less, right? So if I plug in 1, I think about, what does that give me, a positive or a negative? And then over here, if I plug in, you can use your calculator for this too, right? If you plug in, what's bigger than root 50? Root 100 is bigger, so like 10. If I plug in 10, what do I get? I get a negative, okay? So that is definitely my max. I want a largest. And then what is the area? I plug that back into the area formula, and then I find my area, all right? Okay, last one. So this one just, I mean, the concept is the same. It's just, it's very much radicals and things like that, okay? All right, last one. Find the dimensions of a rectangle with the smallest perimeter whose area is 25 centimeters squared. I want the smallest perimeter, so this one, and then perimeter formula is how I'm going to start that, okay? So I start with this. So I have a whole rectangle. I'm going to call one side x, and the area is 25. So something times x equals 25. So, you know, if I solve for that something, divide by 25 on each side, I get, or divide by x on each side, I get 25 over x. So if I multiply these, do I get 25? I do, because area is going to be this times this. So if I multiply, I get 25. I'm good. Okay, so there's my picture. How do you get perimeter? It's this plus this plus this plus this. So 2x plus 50 over x, right? Because there's the top and the bottom. Okay, find your derivative. So you should do this like on your own, and then just check your answers, okay? So find the derivative, set equal to 0, solve, and then I know this is plus or minus 5, but it's a rectangle, so it can't be negative 5, okay? So that's the only reason it's not negative. And then you're going to check it on the number line. When you check it on the number line, it is a minimum, and I want the smallest. So then I make sure I answer the question. Find the dimensions. Okay, the dimensions are going to be this and this. So I plug in 5, and I get 5 by 5 centimeters. Okay, so we're going to give this a try tomorrow. Today is just the notes. Make sure that you ask questions tomorrow if you have questions about the notes, and I'll see you later.